Hello, 8th grade science. This is our first instructional video for Unit 4, Week 4, our last kind of unit of learning, and we're really focusing this week on learning about Newton's third law. So to kind of review, we learned about Newton's first law: objects in motion will stay at motion, objects at rest will stay at rest unless acted upon by an outside force. We learned about Newton's second law, which is force equals mass times acceleration, and kind of how all those different force, mass, and acceleration, how they relate to each other and impact each other in terms of what we see throughout, our natural daily world. And now we have Newton's third law, the last of Newton's laws about motion. And really the goal today is to learn about that. We're going to be learning a kind of a new phrase, which is called action-reaction pairs. You guys have secretly been learning these this entire unit. We just haven't called them that yet. And so with Newton's third law, we're going to call them out specifically. You're going to be able to explain motion under Newton's third law, how it kind of makes sense, stuff you've actually kind of been doing already throughout this whole unit as well. You just didn't know it. And also try and start thinking about creating a solution to minimize forces. And that kind of relates to our assignment. I'll talk about that here in the directions down there. If you look at kind of the lesson plan portion, we have some bell work. This video is the last of those Newton's laws in space. So they'll demonstrate Newton's third law in space and kind of see it before you learn about it. And then there are some notes. So that's what I want to go over with right now. So these are kind of like the last ones where there's boxes for you to type. The pictures are done for you, but you're typing everything there. This is like the filled out portion. So this is what I'm going to focus on. So Newton's third law, if you can read that in Miss Under's beautiful handwriting. Newton's third law is essentially for every action, there's an equal and opposite reaction. So when we've been learning about a lot of these, like you probably have noticed, whenever there's gravity, there's always a normal force. Whenever there's a downward pull from gravity, which is present everywhere, there's always usually something holding it up. In this case, that's usually what we call the normal force. Could be the ground, the table, whatever the object is it's resting on, we call it the normal force. You probably notice that those are always in pairs and they're equal and they're opposite because there's no movement. So we have gravity pulling down, the normal force holds it up. The book, let's say, sitting on a table will just sit there. That's a really good example of Newton's third law. If we kind of read the clarification, so that acts with the same momentum and in the opposite velocity. So that confuses me, but I like the example better. So a really good example is a balloon. So the action force is the air coming out of the balloon, right? If I put my finger and let the air out of the balloon, I can feel the air coming out. That's an action force. But what direction does the balloon go? It goes the opposite way the air is going. The air is going this way, but the balloon goes the opposite direction. That's because of the reaction force. You can kind of see that in that demo. There's some more examples as well, right? So if I'm diving off a diving board, I'm shoving down on the diving board. What does the diving board do? It makes me go up. I apply a force on one object, the diving board, pushing down. The diving board applies an opposite force on me, pushing me up. Think about it with a skateboarder. I think that's what that's supposed to be. Maybe you're just sliding on the skateboard, I think. But if I kick a skateboard, right, I might shove it backward and it might make me want to fall forward. I think it's more, it's jumping off a skateboard. Yeah, if you jump off a skateboard, right, it'll fly behind you while you go forward. It's kind of scary, actually, if you ever do that. So those are the notes on Newton's laws. Oh, is the explanation not there? If I open the teacher notes, no, I'll fix that. I'm going to pause. I got to go find the explanation underneath here just to make sure we got our bases covered. I'll link this on here, but to finish the thought, those are the explanation forces. And we kind of talked about it already, but I will link this whole PDF on here so that you have that. But that's kind of the rest of your notes. And then really we're just going to be exploring that concept or idea in your assignment, this Jamboard assignment. So make sure you tune in for the directions for that. I think once you've done this, the Jamboard assignment, and filled up the notes, it'll really click in your head. Because like I said, we've been kind of learning this without saying it this whole unit. Have a good rest of your day. Bye.